1944, German tank crews called it a Tommy Cooker. They mocked its thin armor. They laughed at its 75mm gun. But when their Panthers broke down for the third time that week, and their Tigers couldn't reach the front because they ran out of fuel, those same German crews started capturing Shermans and refused to give them back. This is the untold story of the tank that won World War II, not with firepower, but with something the Germans could never match: reliability. And the confession you're about to hear will shock you. December 1944, the snow-covered forests of Belgium. An American M4 Sherman tank crew huddles inside their steel box, knowing that somewhere in those trees, German Panther and Tiger tanks are waiting. The crew knows the brutal math. The Sherman's 75mm gun can't penetrate a Panther's front armor at any practical range. Meanwhile, the Panther's 75mm can slice through a Sherman like butter from over a mile away. British tankers had given the Sherman an unflattering nickname, Ronson, after the cigarette lighter with the slogan "Lights first every time." The grim joke referenced the Sherman's tendency to burn when hit. German crews called them Tommy Cookers. The reputation was brutal and in many ways deserved. The numbers seemed damning. The Sherman weighed 66,800 pounds, with armor ranging from just 0.59 to 2.99 inches thick. Compare that to the Panther's 100,000 pounds and armor up to 4.7 inches thick, or the Tiger's 120,000 pounds with armor up to 7 inches thick. On paper, sending Sherman crews into battle against these German monsters seemed like murder. General Lucius Clay would later recall with brutal honesty, "We were never able to build a tank as good as the German tank, but we made so many of them it really didn't matter." That statement has defined the Sherman's reputation for decades. The tank that won by numbers alone. Quantity over quality. Crews sacrificed because America's industrial machine could replace losses faster than Germany could inflict them. But that narrative, while popular, misses the bigger picture entirely. The M4 Sherman wasn't designed in 1941 to fight Panthers and Tigers. Those German tanks didn't exist yet. The Sherman was designed to be reliable, maintainable, producible, and versatile. It was designed to do a job, and do it consistently across deserts, forests, jungles, cities, and mountains. From North Africa to the Philippines, from Sicily to the Rhine, in British, American, Canadian, French, and even Soviet hands, nearly 50,000 Shermans rolled off assembly lines between 1942 and 1946. They were built by auto manufacturers, Chrysler, Ford and General Motors, companies that knew how to mass-produce reliable vehicles. The Sherman inherited Detroit's obsession with mechanical dependability and ease of maintenance. When the first Shermans arrived in North Africa in late 1942, they proved superior to German Panzer IIIs and Panzer IVs, the actual tanks they were designed to fight. They were faster, more reliable, and had better gun stabilization. American crews could fire accurately on the move, while German tanks had to stop to shoot effectively. The problem came later. In 1943, Germany deployed the Panther and Tiger in response to Soviet T-34s on the Eastern Front. These were heavy tanks or specialized medium tanks with thick armor and powerful guns. They weren't designed for the same role as the Sherman. Comparing them was like comparing a sports car to a truck. Different tools for different jobs. But on the battlefield, such distinctions didn't matter to the tankers getting shot at. The psychological impact was immense. Crews who saw their shells bounce harmlessly off Panther armor while watching their friends burn in knocked-out Shermans developed an understandable hatred for their own machines. Yet something curious happened as the war progressed, something that would only come to light years later, when historians examined German records and interviewed enemy tank crews. The Germans started stealing Shermans, and they loved them. To understand why German crews prized captured Shermans, you need to understand what reliability meant in World War II tank warfare. The Sherman used 4 different engines during its production run, but the most common were the Continental R975 9-cylinder radial aircraft engine, producing 400 horsepower, and later the Ford GAA V8 producing 500 horsepower. These weren't cutting-edge designs, they were proven, reliable power plants adapted from existing technology. In June 1943, U.S. Army testing determined the average Sherman service life at 1,500 miles. The Soviet 6th Guards Tank Army, using Lend-Lease M4A2 diesel Shermans, reported lifespans of 2,000 to 2,500 kilometers, roughly 250 to 300 hours of operation. This matched their T-34s, which Soviets considered excellent, but testing revealed something more important than pure endurance: ease of maintenance. In trials conducted in late 1943, 20 Sherman variants drove across 3 types of terrain: fine loose sand, clayey stony ground, and highways. Mechanics could replace any component except internal engine parts. The M4A4, with its Chrysler multibank engine, required just 45 hours of maintenance per tank during the trial. The diesel M4A2 required 143 hours for engine maintenance, but remained highly rated. Ford GAA engines averaged 255 hours before internal component failure, exceptional for the era. Compare this to German tanks. The Panther's Maybach HL230 engine was notorious for catching fire, especially in early models. The engine compartment was poorly ventilated, fuel lines were vulnerable, and the complex transmission failed frequently. Panthers often broke down before reaching the battlefield. A British officer commanding Sherman reliability trials in 1943 compared them to British Cromwell tanks and concluded, "They are utterly reliable. I do not think they are quite as good as the Cromwell across country when running on worn rubber tracks, but they appear so infinitely superior in every other way, particularly in reliability with minimum maintenance, that this cross-country consideration is completely outweighed. The Sherman's design emphasized interchangeable parts. A suspension bogie, the wheels and springs assembly, could be unbolted from one tank and bolted onto another in minutes. The front-mounted transmission could be completely removed without specialized tools. Crews could perform field repairs that would require factory work on German tanks. This modularity extended to everything. The Sherman used standardized components wherever possible. If a radio failed, you swapped it. If an engine threw a rod, you pulled the entire power pack and replaced it. German tanks, by contrast, required specialized tools, trained mechanics, and often factory-level teardowns for similar repairs. The Sherman's 5-man crew included positions designed around efficiency. The driver and assistant driver sat in the front hull. The commander, gunner, and loader worked in the spacious turret with a massive 69-inch diameter turret ring, larger than the Panther's 65-inch ring, despite the Sherman being a smaller tank overall. This turret ring size had profound implications. It meant the Sherman could accommodate gun upgrades without major redesign. The British mounted the 17-pounder anti-tank gun, one of the war's best, in the Firefly variant. Americans fitted the 76mm M1 gun in later models. The basic hull could accept these improvements because the design had room to grow. German tanks were pushed to their design limits from the start. The Panther couldn't be significantly improved without total redesign. The Tiger II was so heavy it broke bridges and couldn't use many roads. Complexity meant more things could break, and did. Soviet tanker Dmitry Loza, who commanded Lend-Lease Shermans, praised their reliability and ease of maintenance. He specifically appreciated the auxiliary power unit that charged batteries without running the main engine, something T-34s lacked. The Sherman wasn't just a tank. It was a product of American automotive engineering philosophy. Build it tough, make it fixable, and keep it running. Statistics from World War II tank combat reveal truths that contradict popular mythology about the Sherman. Between June and November 1944, U.S. Army operational research analyzed tank versus tank engagements in the European theater. The data showed that in direct combat between Shermans and German armor, the critical factor wasn't armor thickness or gun caliber. It was who saw whom first and who fired first. When Shermans spotted German tanks first and fired first, they won approximately 80% of encounters, even against Panthers. When Panthers spotted Shermans first, they won approximately 70% of encounters. The advantage of surprise and first shot outweighed technical specifications. This makes sense when you consider combat reality. Tank battles rarely occurred at maximum effective range in open terrain. Most engagements happened at 500 to 800 yards in cluttered environments, towns, forests, and farmland. At these ranges, a Sherman 75-meter gun could penetrate Panzer IV side and rear armor. The 70-meter Sherman could threaten even Panthers from the side. The famous 5 Shermans to kill 1 Panther myth appears nowhere in actual combat records. Military historian Stephen Zaloga searched extensively for its origin and concluded it's likely a misunderstanding of U.S. Army doctrine. American tank platoons consisted of 5 tanks, so yes, 5 Shermans would be sent to engage enemy armor, but that was organization, not casualties required. Actual loss rates paint a different picture. In northwestern Europe from 1944-1945, Shermans achieved roughly 1.2.1 kill ratios against Panthers in direct tank versus tank engagements, meaning Shermans actually destroyed slightly more Panthers than they lost. This happened because Shermans were attacking, had numerical superiority, better crew training in later war, and superior logistics keeping them operational. But most tank losses didn't come from other tanks. U.S. Army analysis showed that anti-tank guns, mines, and Panzerfaust infantry anti-tank rockets caused 70–80% of Sherman losses. This was true for German tanks too. The Tiger's thick armor was irrelevant against a mine or a Panzerfaust striking from 30 yards. Production numbers are equally revealing. Germany manufactured approximately 6,000 Panthers, 1,147 Tigers, and only 492 Tiger IIs during the entire war. By comparison, the US produced 49,034 Shermans. But Germany also produced 8,500 Panzer IVs and over 10,000 Stug 3 assault guns, vehicles roughly comparable to Shermans. The key difference: Sherman production was efficient and sustainable. American factories could produce a Sherman for approximately $45,000 to $50,000. A Panther cost roughly $100,000 and a Tiger over $250,000. Germany spent 3 times the resources to build a tank that broke down more frequently and was harder to repair. Reliability metrics are stark. In spring 1944 testing, a Sherman M4A3 covered 2,097 miles in 203 hours before failure. Panthers frequently broke down within their first 150 kilometers. The Tiger's final drive was so problematic that it often failed after fewer than 100 miles. This meant that while a Panther might be superior in a single engagement, divisions equipped with Shermans could sustain operations continuously. German armored units spent weeks waiting for spare parts and conducting maintenance. American armored divisions kept moving. The Sherman's mechanical availability rate, the percentage of tanks operational at any given time, averaged 85–90%. Panthers rarely exceeded 50% operational availability, and Tigers often fell below 40%. An army with half its tanks broken down loses to an army with most of its tanks running. Regardless of individual tank superiority, the numbers told a story German commanders understood all too well. Reliability was a combat multiplier that outweighed raw firepower. The most revealing evidence of the Sherman's quality comes from an unexpected source: German crews who captured and used them. Throughout the war, German forces captured hundreds of Shermans from American, British, and Soviet forces. The Wehrmacht designated captured Shermans as M4 748A, the A denoting American origin. Unlike captured Soviet T-34s, which Germans often modified extensively, they used Shermans exactly as designed. Photographic evidence and German after-action reports reveal crews who captured Shermans looked remarkably pleased with their new machines. Contemporary captions on German photos show crews praising the Sherman's reliability, fuel economy, and comfort compared to Panzer IIIs and IVs they'd previously operated. One revealing photo shows a late-production M4A2 diesel Sherman with a German crew. The original caption noted the crew was very pleased with the tank because it was more reliable, got better gas mileage, and was more comfortable than the Panzer III or IV they were stuck in before. German mechanics discovered the Sherman was a breath of fresh air in troubleshooting and maintenance. Even the complex Chrysler A57 multibank engine, 5 automobile engines connected to a single drive shaft, was easier to diagnose and repair than Panther transmissions or Tiger final drives. Germans particularly valued captured Shermans as armored recovery vehicles, ARVs. They would remove the turret and use the Sherman hull to recover broken-down German tanks. This tells you everything. Even Nazi tank crews recognized that Sherman powertrains were tougher and more reliable than their own vehicles. The German desperation for tanks meant they eagerly employed any Sherman they could capture and repair. Some Shermans captured during the Battle of the Bulge in December 1944 were repainted with German crosses and put immediately into service. One M4A3 76mm Sherman captured from the U.S. 4th Armored Division was used in the defense of Aschaffenburg, Germany in spring 1945, where it was finally destroyed by an American M36 tank destroyer. Historical records show German crews sometimes abandoned their own tanks without booby-trapping them, simply walking away when Panthers broke down or ran out of fuel. This was particularly common in late 1944, as fuel shortages became critical and spare parts vanished. Conversely, Germans fought hard to keep captured Shermans operational, scrounging parts and fuel to maintain them. Soviet tanker testimonials provide another perspective. The USSR received over 4,000 Shermans through Lend-Lease. Many Soviet crews preferred them to T-34s. Dmitry Loza commanded the 46th Guards Tank Brigade, equipped with M4A2 Shermans. His memoir praised their reliability, noting the Sherman rarely broke down, and when it did, repairs were straightforward. Soviet crews appreciated specific features: the auxiliary power unit for battery charging, the gun stabilizer that allowed firing on the move, and the spacious interior that made long operations less fatiguing. The 5-man crew was also superior to the T-34's 4-man arrangement, which overworked the commander who also served as gunner. The T-34 had cramped interiors, poor visibility, difficult manual transmission, and primitive crew accommodations. Soviet tankers noted that Shermans were simply more pleasant to fight in, important during multi-day operations. Loza specifically mentioned that Sherman crews experienced less fatigue and could maintain combat effectiveness longer. French forces also received Shermans and continued using them into the 1950s. Interestingly, France tried using captured German Panthers after the war, but quickly abandoned them as utterly unusable due to mechanical unreliability. French tank units standardized on Shermans. Instead, even Israel's army used upgraded Shermans well into the 1960s and even the early 70s. The basic hull and mechanical design proved so sound that with new engines, guns, and armor, Shermans remained combat effective decades after WBs ended. No German WP tank design showed similar longevity. The ultimate compliment came from enemy crews who, given the choice between their own nation's tanks and captured Shermans, chose the Sherman. That speaks louder than any technical specification. December 16, 1944. Germany launched its last major offensive in the West. Operation Wacht am Rhein, known to history as the Battle of the Bulge. Over 200,000 German troops, supported by nearly 1,000 tanks and assault guns, smashed into lightly defended American positions in the Ardennes forest. The German plan depended on speed. Panzer divisions needed to reach the Meuse River within 48 hours and capture Allied fuel depots, because Germany couldn't provide enough fuel for the operation. German tanks would literally run on captured American gasoline. The offensive achieved initial surprise. American units were overrun and German armor pushed westward. But within days, the plan began unraveling, not primarily due to American firepower, but due to German mechanical failures. Panthers and Tigers broke down in staggering numbers. The cold weather caused already problematic German transmissions to fail completely. Fuel lines froze. Engines wouldn't start. German maintenance crews worked frantically, but many tanks were simply abandoned when they couldn't be repaired quickly enough. American Sherman units, meanwhile, kept operating. The Sherman's automotive reliability proved decisive in the chaotic winter conditions. When Panthers broke down blocking narrow forest roads, the entire German advance behind them stalled. Shermans could bypass obstacles, recover disabled vehicles, and maintain mobility. The U.S. 7th Armored Division held the critical town of St. Vith for 6 days against overwhelming German forces. The Shermans operated continuously in sub-zero temperatures, providing mobile firepower that stabilized the defense. German after-action reports noted frustration that American tanks remained operational while their own Panthers sat disabled. At Bastogne, the 101st Airborne Division was surrounded but supported by armored units, including Sherman-equipped tank battalions. When General Patton's Third Army conducted a relief operation, his Sherman-equipped 4th Armored Division covered 150 miles in 3 days through winter weather, a pace German Panther units couldn't match even in summer. The breakthrough to Bastogne on December 26 relied entirely on Sherman mobility and reliability. The 4th Armored Shermans fought continuously for 72 hours with minimal maintenance. German tanks opposing them spent as much time being repaired as fighting. Weather played an equalizer role. In early stages, heavy fog grounded Allied aircraft, eliminating the American air superiority advantage. This meant tank versus tank combat and artillery duels, contexts where German armor supposedly excelled. Yet American armored units held their ground and even counterattacked successfully. The Sherman's mechanical reliability meant American commanders could count on their tanks being available. German commanders constantly faced situations where planned armored operations couldn't execute because half their tanks were broken down. Logistics records showed German armored divisions at 30–40% operational strength by late December. Not primarily from combat losses, but mechanical failures. Fuel consumption also mattered critically. A Sherman M4A3 traveled approximately 100 miles on a full tank of gasoline. A Panther managed about 60 miles and a Tiger about 50 miles, and that's under ideal conditions. In winter warfare with poor roads, German fuel consumption increased dramatically. By December 24th, many German armored units were immobilized not from combat damage, but from empty fuel tanks and broken transmissions. The captured American fuel depots they desperately needed remained in Allied hands. German tanks sat silent, while American Shermans continued moving, shooting, and supporting infantry. When the Battle of the Bulge ended in late January 1945, German losses included over 600 tanks and assault guns. Many were simply abandoned, out of fuel or broken down, as German forces retreated. American losses were comparable in numbers, but U.S. industrial capacity replaced them within weeks. Germany couldn't replace theirs at all. The battle proved that in sustained combat, reliability, fuel efficiency, and maintainability mattered as much as armor and firepower. The Sherman had those qualities. German armor didn't. The Sherman's reputation as a death trap persists in popular culture. But statistical analysis reveals a more complex truth. Crew survival rates tell an interesting story. U.S. Army analysis from 1945 showed that when a Sherman was knocked out, approximately 80–85% of the crew escaped. This was the highest escape rate of any tank in the war. By comparison, T-34 crews had roughly 50% escape rates, and German tank crews varied widely depending on the vehicle. The Sherman's design contributed to high crew survival. It had large hatches that opened outward. The crew compartment was spacious enough for men to move quickly. The ammunition was stored low in the hull, and later models used wet stowage with water-jacketed ammunition bins that dramatically reduced fire. Risk-got early Shermans did have a tendency to catch fire when penetrated. This was primarily due to ammunition storage arrangements that placed shells in vulnerable sponsons above the tracks. When a round penetrated, it often struck ammunition, causing catastrophic fires. The U.S. Army recognized this problem in 1943 and implemented wet stowage by 1944. Ammunition bins were lined with water jackets and glycerin solution. If a penetrating round struck them, the liquid would cool the ammunition and suppress fires. This modification reduced fire rates by approximately 80%. Late-war Shermans with wet stowage, designated with a W, like M4A376W, were significantly safer. British studies showed these tanks had fire rates comparable to or lower than German tanks. The earlier Ronson reputation stuck, despite the problem being largely solved. Regarding the Tommy Cooker nickname, post-war research suggests this wasn't actually widely used by German soldiers. It appears more commonly in post-war literature than in contemporary German documents. Germans typically called Shermans simply Shermans, or occasionally Mickey Mouse tanks due to rounded shapes. The more serious question is comparative lethality. Were Shermans more likely to kill their crews than other tanks? Data is incomplete, but available evidence suggests no. Soviet T-34s had worse crew survival rates, despite being lauded as excellent tanks. German Panthers caught fire frequently, especially early models, where engine fires were common, even without enemy action. Tigers were rare enough that statistical comparisons are. Difficult American tanker mortality rates were approximately 3% of armored division personnel, lower than infantry mortality rates of 15–20%. This suggests tank service, while dangerous, wasn't the death sentence popular myth suggests. Tankers had better survival odds than infantrymen. The book Death Traps by Belton Cooper, an armored maintenance officer, heavily influenced the Sherman's negative reputation. Cooper's anecdotes described horrific casualties and burning Shermans. However, historians have noted Cooper's position as a maintenance officer meant he saw every disabled tank but rarely saw successful operations. His perspective was systematically biased toward casualties. Combat analysis showed that most tank losses occurred from mines, anti-tank guns, and infantry weapons, not tank versus tank combat. The Sherman's armor was adequate against these threats most of the time. When it failed, crew survival rates were relatively good compared to other armies' experiences. The psychological impact of facing superior German tanks shouldn't be minimized. Sherman crews knew their tanks were outmatched by Panthers and Tigers in direct combat. That knowledge was terrifying, but the actual statistical risk was lower than crews believed. A common phenomenon in warfare where perceived danger exceeds actual danger. Modern analysis suggests the Sherman was roughly as safe as other W2 tanks, with better crew escape rates than most. The reputation as a death trap is more myth than mathematical reality. But myths can be more powerful than facts, especially in shaping historical memory. The Sherman's greatest strengths came from an unlikely source: American automobile manufacturers. In 1940, the U.S. Army approached Detroit with an unprecedented request. Could civilian auto factories produce tanks? Could assembly line techniques that churned out thousands of cars monthly adapt to military production? The answer would change warfare forever. Chrysler, Ford, And General Motors didn't just manufacture tanks, they reimagined tank production using automotive industry principles, standardization, interchangeable parts, modular design, quality control procedures. These concepts were revolutionary in military manufacturing. Previous tank production relied on custom-fitted parts and hand assembly techniques. Each tank was slightly different. Repairs required skilled craftsmen who could file, fit, and adjust replacement parts. This approach worked for low production numbers but couldn't scale. Detroit's approach was different. The Sherman was designed from the start for mass production. Parts were manufactured to precise tolerances, so any component from any factory would fit any tank. A transmission from Chrysler's Detroit arsenal would bolt into a hull from Ford's River Rouge plant without modification. This interchangeability extended throughout the tank. Suspension bogies, track links, engine components, guns, radios, all standardized. The U.S. produced tanks the way it produced Model T Fords, as products, not custom vehicles. The Sherman's design emphasized ease of assembly and disassembly. The front-mounted transmission could be unbolted and removed in about an hour with basic tools. The vertical volute spring suspension, VVSS bogies, could be replaced individually without disturbing adjacent components. The turret could be lifted off completely for major repairs. German tanks, by contrast, used complex overlapping road wheels, especially on Panthers and Tigers, that required removing multiple wheels to replace inner ones. Transmissions were deeply integrated into the hull. Repairs that took American crews an hour took German crews days, if they had parts and tools available. Quality control was another American advantage. Detroit factories implemented statistical quality control, a relatively new concept in the 1940s. Parts were measured and tested. Defect rates were tracked. Production lines stopped when quality issues appeared. This ensured that Sherman tanks left factories in consistent, reliable condition. German production, especially late in the war, used slave labor and operated under constant Allied bombing. Quality control was inconsistent. Sabotage occurred. Some Panthers left factories with cigarette filters jammed in oil, passages or improperly torqued bolts, ensuring failure but difficult to detect during initial inspection. The Sherman's design also anticipated upgrades. The large turret ring could accommodate bigger guns. The engine compartment could fit various power plants. The suspension could handle weight increases within limits. This future-proofing meant the basic Sherman design remained viable throughout the war and beyond. Compare this to the Panzer IV, which started the war as Germany's main medium tank. By 1945, the Panzer IV was at the absolute limit of its design. Adding more armor strained the suspension. The small turret ring prevented significant gun upgrades. Further development was impossible without complete redesign. American automotive engineering culture emphasized reliability over performance. A car that broke down constantly was commercially worthless, regardless of its top speed. This philosophy transferred directly to tank design. The Sherman prioritized reliability over cutting-edge performance. German engineering culture, particularly in military applications, often prioritized peak performance over reliability. Tigers and Panthers represented this mindset. Incredible capability when working, but working less often than needed. The Sherman also reflected American logistical thinking. It was designed to be shipped overseas. Width and weight were constrained by shipping capacity and the need to cross bridges. It had to work with available fuel supplies. These practical considerations shaped every design decision. Detroit's contribution to Allied victory is often overlooked, but it was fundamental. The Sherman wasn't just a tank. It was a product of American industrial philosophy applied to warfare. And that philosophy valued reliability above all else. The Sherman's reputation varies dramatically depending on who's asked. Soviet and British users provide perspectives distinct from American experiences. The Soviet Union received 4,065 M4A2 diesel Shermans through Lend-Lease, primarily serving in Guards tank units. elite formations. Soviet employment differed from American doctrine, but crew reactions were consistently positive. Dmitry Loza, commanding the 46th Guards Tank Brigade, equipped entirely with Shermans, wrote extensively about his experiences. His memoir provides rare Soviet perspective on American equipment. Loza praised the Sherman's mechanical reliability, noting it rarely broke down, compared to T-34s, which frequently required field repairs. Soviet crews particularly appreciated the auxiliary power unit, a small gasoline engine that could charge batteries and power radios without running the main engine. T-34s lacked this feature, forcing crews to run main engines for radio operations. Wasting fuel and revealing positions, the Sherman's 5-man crew arrangement was superior to the T-34's 4-man layout. In T-34s, the commander also served as gunner, overloading him with responsibilities. Sherman commanders could focus on tactical situation awareness, while the gunner engaged targets. This improved combat effectiveness, especially in sustained operations. Soviet tankers noted the Sherman's superior crew ergonomics. The interior was spacious, visibility was better, and controls were less fatiguing to operate. During multi-day operations, these factors significantly impacted crew performance. Exhausted crews make mistakes and fight less effectively. However, Soviet crews had criticisms. They considered the Sherman too tall, making it more visible and easier to hit. They disliked the gasoline engine. Even though their M4A2s were diesel, they associated Shermans with gas engines generally. Some felt the armor was inadequate compared to heavy German tanks, but these criticisms should be contextualized. Soviet tankers faced the full weight of German armor on the Eastern Front, including the vast majority of Panthers and Tigers. Their expectations were shaped by extremely intense combat conditions. That Soviet Guards units continued using Shermans throughout the war speaks to overall satisfaction. British experiences with Shermans were extensive. Britain received over 17,000 Shermans through Lend-Lease, making it the primary British tank from 1942 onwards. British crews initially used American 75mm gun Shermans, then developed the Firefly variant, mounting the excellent 17-pounder anti-tank gun. British 1943 reliability trials compared Shermans to British Cromwell and Centaur tanks. The British officer commanding concluded Shermans were utterly reliable with minimum maintenance, outweighing any cross-country performance deficiencies. British armoured divisions standardized on Shermans specifically because of reliability. The Firefly variant solved the firepower issue. The 17-pounder gun could penetrate any German tank from front at reasonable combat ranges. British tactical doctrine placed one Firefly in each tank troop, platoon, providing specialized anti-tank capability, while other Shermans handled infantry support. British tankers gave the Sherman mixed reviews. They appreciated reliability and ease of maintenance, but shared American concerns about armor and gun effectiveness. The Ronson nickname originated with British crews. However, operational commanders consistently praised the Sherman's logistical advantages. Post-war, Britain continued using Shermans into the 1950s. British forces deployed Shermans during the 1956 Suez Crisis. Meanwhile, Britain scrapped nearly all captured German tanks as unusable. This practical choice reveals professional military assessment. Reliable Shermans were more valuable than prestigious but problematic German armor. Canadian forces also used Shermans extensively, sharing British and American experiences. French units equipped with Shermans during liberation praised their reliability. Polish armored units operating with British forces used Shermans successfully. International users consistently identified the same strengths: reliability, maintainability, and availability. These unglamorous qualities won wars. Popular narratives pit Shermans against Tigers and Panthers. Reality was more complex. The vast majority of German armor Sherman crews encountered wasn't elite heavy tanks. It was Panzer IIIs, Stug 3 assault guns, and various improvised tank destroyers. The Panzer IV was Germany's workhorse medium tank, produced in larger numbers than any other German tank, approximately 8,500 units. It was comparable to the Sherman in weight, armor, and role. Late-war Panzer IVs mounted the long 75mm KWK-40 gun, which was effective but not overwhelming. In tank versus tank combat, Shermans and Panzer IVs were relatively evenly matched. The Panzer IV had a slight edge in gun penetration. The Sherman had better reliability, gun stabilization, crew comfort, and faster turret traverse. In actual combat, crew quality and tactical situation mattered more than technical differences. Combat records show Shermans achieved favorable exchange rates against Panzer IVs. Neither tank dominated, both could destroy the other at typical combat ranges. The Sherman's numerical superiority and better operational availability gave American forces overall advantage. The Stu G3 assault gun was Germany's most produced armored vehicle, with over 10,000 built. It mounted powerful guns, but lacked a turret, limiting tactical flexibility. Tugis were primarily defensive weapons and tank destroyers. They were deadly in ambush, but vulnerable to flanking attacks. Shermans faced Stu Gs frequently and generally handled them successfully. The Sherman's turreted design allowed responding to threats from any direction. Stu G crews had to turn the entire vehicle to aim, giving Shermans critical time advantages in close combat. Panthers and Tigers are what everyone remembers, but they were uncommon. The US Army estimated encountering them in only 10–15% of tank combat situations. The rest of the time, Shermans fought Panzer IVs, Stu Gs, and various lighter vehicles. When Shermans did encounter Panthers or Tigers, outcomes varied widely. In open terrain at long range, German heavy tanks had decisive advantages. But in towns, forests, and close terrain, where most combat occurred, the situation was much more even. The Sherman's numbers allowed tactical approaches that negated German advantages. American doctrine emphasized combined arms. Tanks worked with infantry, artillery, and air support. Shermans wouldn't charge Panthers head-on. They'd suppress them with artillery, flank them with infantry support, or call in airstrikes. One underappreciated Sherman advantage was crew training. American tankers received extensive training before deployment. German crews, especially late in the war, often arrived at the front with minimal preparation. Well-trained crews in adequate tanks consistently defeated poorly trained crews in superior tanks. German tank destroyers like the Jagdpanzer IV and Hetzer were more common opponents than Tigers. These turretless vehicles mounted powerful guns, but had the same tactical limitations as Stu Gs. Sherman crews learned to exploit their lack of turret traverse and limited visibility. The most dangerous German anti-tank weapon wasn't tanks at all. It was the Panzerfaust. This disposable infantry anti-tank rocket could destroy any Allied tank from close range. Likewise, towed anti-tank guns and mines caused the majority of Sherman losses. Against these threats, the Tiger's heavy armor offered no more protection than the Sherman's. Context matters enormously. In the flat, open terrain of North Africa or the Russian steppes, heavy German tanks with powerful guns had maximum advantage. In the hedgerows of Normandy, the forests of the Ardennes or Italian mountain towns, close-range combat negated armor and gun advantages. The Sherman was designed as a universal medium tank, a jack of all trades. It wasn't optimized for single-purpose tank duels. It was meant to support infantry, exploit breakthroughs, fight other medium tanks, and occasionally duel heavy armor when necessary. German armor was increasingly specialized. Panthers were designed to counter Soviet T-34s. Tigers were breakthrough weapons. Stu Gs were defensive. Each excelled in its role, but struggled outside it. The Sherman's versatility meant it could handle varied situations adequately, if not spectacularly. Statistical analysis consistently shows that the most important factors in tank combat were seeing first, shooting first, and hitting first. These depended on crew quality, tactical situation, and luck more than technical specifications. The Sherman's reliability meant it was available to fight. The tank that's broken down can't see, shoot, or hit anything at all. The Sherman's true legacy isn't about armor thickness or gun caliber. It's about understanding that wars are won not by the best equipment, but by adequate equipment in overwhelming quantity, reliably maintained and continuously available. Nearly 50,000 Shermans were produced between 1942 and 1946. This staggering number reflects American industrial capacity, but also design choices that made such production possible. The Sherman could be manufactured quickly, efficiently, and consistently because it was designed for mass production from the start. These tanks served on every front in World War II, from the deserts of North Africa to the jungles of Burma, from the beaches of Normandy to the islands of the Pacific. Shermans fought in every climate and terrain imaginable. No other tank design showed such universal applicability. The Sherman's post-war service life reveals its fundamental soundness. Israel used upgraded Shermans until the 1970s, 3 decades after initial design. The Super Sherman, with French 105mm guns and modern diesel engines, fought effectively in the 1967 Six-Day War and 1973 Yom Kippur War. No German world. War II tank design showed similar longevity. Multiple nations used Shermans for decades after W2. Argentina, Chile, India, Pakistan, Paraguay, and others operated Shermans into the 1980s and even 1990s for secondary roles. The basic mechanical design was that solid and adaptable. The Sherman influenced post-war tank design significantly. The concept of a reliable, maintainable, mass-producible medium tank became standard. Soviet T-54-55 series, American M48 pattern, and British Centurion all reflected lessons from Sherman development, prioritize reliability and production efficiency alongside combat capability. German tank design philosophy, high-performance specialized vehicles in limited numbers, was decisively rejected. Post-war analysis showed it had failed. Complexity, maintenance demands, and production challenges made German heavy tanks strategically counterproductive despite tactical effectiveness. The Sherman taught armies that mechanical reliability is a combat multiplier. An elite tank that's broken down half the time is strategically inferior to an adequate tank that's available 90% of the time. Modern military procurement still struggles with this lesson, frequently prioritizing peak capability over sustained availability. Logistics and maintenance matter as much as firepower. The Sherman's design recognized this from the start. It could be repaired with common tools by moderately trained crews. Parts were interchangeable and widely available. This unglamorous reality won more battles than any superweapon could. The confession that gives this video its title comes from multiple sources. German crews who captured Shermans consistently praised their reliability. German commanders in post-war interviews acknowledged that American logistical superiority, keeping tanks running, supplied, and operational, was decisive. German technical superiority in individual vehicle performance couldn't overcome American reliability and numbers. A particularly telling incident occurred during the Battle of the Bulge. A German Panther battalion commander, when his tanks broke down yet again, was reported to have said in frustration, "Give me a dozen Shermans and I could win this war. At least they run." That sentiment captures the essential truth. The Sherman wasn't the best tank on the battlefield in any single category except reliability. But reliability turned out to matter most. Wars aren't won by superweapons. They're won by adequate weapons, produced in quantity, kept in working order, supplied with fuel and ammunition, and operated by well-trained crews. The Sherman exemplified this principle perfectly. The tank everyone loved to hate was actually the tank that won the war. Not through superiority in combat, but through availability, reliability, and persistence. German crews mocked it until they drove it. Then they understood. The M4 Sherman wasn't just a tank. It was a lesson in military-industrial strategy that remains relevant today. Perfection is the enemy of good enough. Complexity is the enemy of reliability. And in war, the weapon that works wins, regardless of whether it's the best on paper. That's the Sherman's real legacy, and why its story matters 80 years later. December 1944, the frozen forests of Belgium. A single American tank crew faces the unthinkable, Germany's most feared weapon, the King Tiger, advancing through the snow. The Americans are outnumbered, outgunned, and driving a tank their own generals almost cancelled. What happens next would rewrite the rulebook of armored warfare and prove that sometimes the underdogs carry the biggest punch. This is the untold story of how American ingenuity defeated Nazi engineering at its peak. The year was 1942, and the United States Army faced a devastating reality. Reports from North Africa painted a grim picture. American M4 Sherman tanks were being systematically destroyed by German panzer forces. The Sherman, America's frontline medium tank, was reliable and mass-produced, but it had a fatal weakness. Its 75mm gun couldn't penetrate the frontal armor of Germany's newer tanks. On November 8, 1942, Operation Torch began, marking America's entry into the North African campaign. Within weeks, tank crews discovered what British forces already knew. The German Panzer IV, equipped with long-barreled 75mm guns, could destroy Shermans from distances where American tanks couldn't fight back. Even worse, intelligence reports warned of something more terrifying. Germany was developing super-heavy tanks with armor so thick that no Allied weapon could stop them. The U.S. Army Ordnance Department convened emergency meetings in early 1943. General Jacob Devers, commanding Army ground forces, demanded a solution. American tank crews were brave, but bravery couldn't overcome physics. When a Sherman's 75mm shell bounced off German armor, it meant death for 5 American soldiers inside. The Ordnance Department knew they needed a tank destroyer, a vehicle with firepower capable of defeating any German armor. But there was fierce debate about the design philosophy. Some generals wanted a fast, light vehicle that could ambush and retreat. Others demanded heavy armor for head-to-head combat. The American military doctrine emphasized mobility and mass production over individual vehicle superiority, a philosophy that had served them well, but was now being challenged by German engineering. In January 1943, the Ordnance Department issued specifications for a new heavy tank destroyer. It needed to mount a gun powerful enough to defeat 200mm of armor at 1,000 yards, the projected protection of Germany's rumored super-heavy tanks. The vehicle had to be mobile enough to keep pace with advancing infantry. And critically, it needed to be producible in American factories without disrupting existing Sherman production. Multiple designs competed for approval. Fisher Tank Division proposed a heavily armored assault gun. Ford suggested a massive turretless design. But one proposal stood out for its audacity. The Detroit Arsenal, led by engineer Henry J. Hatch, proposed mounting a naval gun on a tank chassis. Not just any naval gun, but a modified 90mm anti-aircraft gun, a weapon designed to destroy bombers at 30,000 feet. The idea seemed absurd to many officers. General Leslie McNair, architect of American tank destroyer doctrine, initially opposed the concept. He believed tank destroyers should be lightly armored and fast, trading protection for firepower and speed. A vehicle mounting a massive 90mm gun would be heavy, expensive, and contrary to established doctrine. McNair's opposition nearly killed the project before it began, but events in Europe forced a reconsideration. On July 5, 1943, Germany launched Operation Citadel at Kursk, deploying their new heavy tanks en masse. Intelligence reports described monsters: the Panther with sloped armor, the Tiger with an 88mm gun, and rumors of even larger designs. The reports terrified Allied commanders. If Germany could field dozens or hundreds of these vehicles, the invasion of Europe might fail before it began. The pressure mounted through summer 1943. American forces needed a counter to German heavy armor, and they needed it fast. The question wasn't whether to build a heavy tank destroyer anymore. The question was which design would save American lives in the coming invasion of Fortress Europe. The T-95 gun motor carriage project officially began in March 1943, but it faced immediate opposition from the highest levels of military command. The vehicle that would eventually become the T-28 super heavy tank started its life. Surrounded by controversy and doubt, Henry J. Hatch and his engineering team at Detroit Arsenal worked frantically. Through spring 1943, their design was revolutionary but problematic. To mount the 90mm gun and provide sufficient armor protection, the vehicle would weigh over 95 tons, making it the heaviest American armored vehicle ever conceived. It would require a specially designed suspension system, with 2 sets of tracks on each side, 4 tracks total, to distribute the massive weight. The Army Ordnance Committee reviewed the preliminary designs in May 1943. The opposition was fierce. General McNair argued the vehicle violated every principle of American tank destroyer doctrine. It was slow, with a maximum speed of just 8 miles per hour. It was expensive, costing approximately 5 times more than a Sherman tank. Most damning, it couldn't cross most European bridges, limiting its strategic mobility. Colonel Willis D. Crittenberger, commanding the Armored Force Board at Fort Knox, issued a scathing report in June 1943. He calculated that for the cost of one T-95, the Army could produce 5 M10 tank destroyers or 3 M4 Shermans. In a war where industrial capacity determined victory, this seemed like an impossible trade-off. Crittenberger recommended the project be terminated immediately, but the T-95 had a powerful advocate. General George S. Patton, though primarily focused on offensive operations, understood the psychological impact of heavy armor. In July 1943, after reviewing intelligence reports from Sicily, Patton sent a telegram to the War Department. He described watching German Tiger tanks destroy American positions with impunity and the devastating effect on infantry morale. Patton argued that America needed a weapon that could stand toe-to-toe with the heaviest German armor, even if produced in limited numbers. The debate intensified through summer and fall 1943. Engineers proposed modifications to address the criticisms. They designed a system where the outer tracks could be removed for transport, reducing the width from 14 feet 11 inches to 10 feet 4 inches, allowing rail and limited bridge crossing. The armor was redesigned using cast and rolled plate combinations, improving protection while controlling weight. The gun mount was refined to provide better accuracy and faster reload times. In November 1943, intelligence reports confirmed Germany was developing the Jagdtiger, a super-heavy tank destroyer mounting a 128mm gun. The War Department reconsidered the T-95 project. If Germany could field such monsters, America needed a counter. On November 29, 1943, the Ordnance Department authorized the construction of 5 pilot vehicles, but the authorization came with severe restrictions. The T-95 would be classified as an experimental vehicle, not a production model. No mass production would occur until the pilots proved their worth in combat trials. Most critically, the project received low priority for steel allocation and manufacturing capacity. Sherman production couldn't be disrupted, even for a potentially war-winning design. The Detroit Arsenal team began construction in December 1943, but progress was agonizingly slow. Critical components were delayed by higher priority programs. The specialized tracks required new manufacturing processes. The 90mm guns needed modification to fit the tank mount. Engineers worked through the winter, knowing that soldiers were dying in Europe while they struggled with blueprints and metallurgy. By March 1944, as the Allied invasion of Europe approached, the first T-95 pilot was still months away from completion. The rejected design remained stuck in American factories, while German heavy tanks dominated European battlefields. While American engineers struggled with their rejected design, Germany unleashed its most powerful weapon. The Panzerkampfwagen Sig Ausf B, known to the Allies as the King Tiger, or Tiger II, represented the pinnacle of German tank design and the nightmare of every Allied tank crew. Development of the King Tiger began in January 1943, when Hitler personally demanded a super-heavy tank that would dominate any battlefield. German engineer Dr. Ferdinand Porsche competed with Henschel and Zohn for the contract. After extensive trials at the Kummersdorf Proving Grounds, the Henschel design was selected in October 1943, and production began in January 1944 at the Henschel plant in Kassel. The specifications were staggering. The King Tiger weighed 69.8 tons, nearly double the weight of a Sherman. Its frontal armor measured 150 mm thick and sloped at optimal angles, making it effectively impervious to any Allied tank gun at normal combat ranges. The side armor measured 80 mm thicker than most Allied tanks' frontal protection. This massive armor meant the King Tigers could advance across open ground, while Allied tanks desperately tried to find weak points. But armor was only half the story. The King Tiger mounted the fearsome 8.8 cm KWK 43L71 gun, a weapon of devastating power. This long-barreled cannon could penetrate 165 mm of armor at 1,000 meters, using standard ammunition, and even more using special tungsten core rounds. In practical terms, a King Tiger could destroy any Allied tank at ranges exceeding 2,000 meters, while remaining invulnerable to return fire. The first King Tigers reached combat units in May 1944. The 503rd Heavy Panzer Battalion received 45 King Tigers and deployed to Normandy, just after D-Day, June 6, 1944. The psychological impact was immediate and devastating. British and American tank crews reported the horror of watching their shells bounce harmlessly off King Tiger armor, while the German vehicles systematically destroyed Allied positions. On June 13, 1944, near Villers-Bocage, a single King Tiger from the 101st SS Heavy Panzer Battalion engaged British forces. Over 3 hours of combat, this single tank destroyed 11 British tanks and numerous support vehicles before withdrawing without significant damage. The engagement terrified Allied commanders. If one King Tiger could do this, what would happen when Germany fielded hundreds? German propaganda maximized the King Tiger's impact. Newsreels showed the massive tanks crushing obstacles and destroying targets at impossible ranges. Hitler personally visited King Tiger units, posing for photographs with these symbols of German technical supremacy. For German soldiers retreating on all fronts, the King Tiger represented hope that wonder weapons might still achieve victory. By August 1944, approximately 120 King Tigers were in service on both eastern and western fronts. Each one required tremendous resources, 300,000 man-hours to produce, specialized steel alloys in short supply, and highly trained crews capable of operating such complex vehicles. But Germany committed these resources because the King Tiger achieved results. In properly conducted defensive battles, King Tigers destroyed Allied tanks at ratios exceeding 10-1. The Allied response was desperate improvisation. Tank crews learned to target tracks and gun barrels, hoping to disable rather than destroy King Tigers. Artillery was called down on King Tiger positions, trying to score lucky hits on thinner top armor. Most effectively, Allied fighter bombers hunted King Tigers during movement. When they were vulnerable and separated from support, but by autumn 1944, as the Allies approached Germany's borders, the King Tiger remained the most feared weapon on the battlefield. No Allied tank could fight it on equal terms. Something had to change, or the final battles for Europe would cost thousands of American lives. Throughout summer 1944, as Allied forces fought through Normandy's hedgerows, American engineers worked desperately to complete the T-95 program. What began as a rejected design had become America's hope for countering German super-heavy armor. But time was running out. The first T-95 pilot vehicle was finally completed in June 1944, the same month as D-Day. It immediately went to the Aberdeen Proving Ground in Maryland for initial trials. The test results were mixed. The 90mm gun performed spectacularly, delivering the promised armor penetration. The four-track system distributed weight effectively, but mechanical problems plagued the prototype. The transmission overheated during sustained operations. The tracks threw frequently, requiring hours of repair work. The complex suspension suffered stress fractures. Lieutenant Colonel John K. Christmas, head of the test program, submitted his report in July 1944. He noted that while the T-95 possessed unmatched firepower, its reliability was unacceptable for combat operations. The vehicle needed extensive redesign before it could serve effectively. This report nearly ended the program. With Allied forces ashore in France and advancing, some officers argued that the war might end before the T-95 could deploy, making the entire project wasteful. But intelligence from Europe changed everything. In August 1944, the Battle of Falaise Pocket demonstrated the King Tiger's capabilities in defensive warfare. Small numbers of King Tigers fighting from prepared positions inflicted devastating casualties on Allied armor. Reports reached Washington describing Allied tanks burning by the dozens, destroyed by an enemy they couldn't even damage in return. General Dwight Eisenhower, Supreme Allied Commander, personally intervened. In a classified message dated August 18, 1944, Eisenhower requested that the T-95 program receive highest priority for completion. He stated that without a vehicle capable of defeating super-heavy German armor, the final assault into Germany might cost tens of thousands of American lives. Eisenhower's support revitalized the project. Engineers worked around the clock through fall 1944. They redesigned the transmission using components proven in the M26 Pershing heavy tank program, which was running parallel to the T-95. They modified the track system, improving reliability. Most importantly, they upgraded the 90mm gun ammunition, developing special armor-piercing rounds with tungsten cores that could penetrate even greater thicknesses of armor. A second pilot vehicle, incorporating these improvements, was completed in October 1944. The Aberdeen tests resumed in November. This time, results were far more promising. The T-95 achieved its design speed of 8 miles per hour consistently. More impressively, in firing tests against captured German armor plates, the 90mm gun penetrated 200mm of armor at 1,000 yards. Exceeding the original specifications, Lieutenant Colonel Christmas submitted his revised report on November 28, 1944. He recommended immediate limited production of 25 vehicles to be deployed to Europe for operational trials under combat conditions. The Ordnance Department approved this recommendation on December 2, 1944. Production orders went to the Pacific Car and Foundry Company, with delivery scheduled for spring 1945. But events were about to overtake this cautious timeline. On December 16, 1944, Germany launched its last major offensive in the West, Operation Wacht am Rhein, known to Americans as the Battle of the Bulge, saw King Tigers and other heavy German armor smash into lightly defended American positions in the Ardennes forest. The desperate fighting that followed would finally create the conditions where the T-95's capabilities could be properly demonstrated. The rejected designs moment was approaching, though few yet realized it. The race against time was about to become a race against German steel and American blood. December 1944 brought chaos to the Western Front. Hitler's desperate gamble in the Ardennes caught American forces off guard, and German heavy armor exploited the breakthrough with devastating effect. In this crucible of combat, American armor doctrine faced its ultimate test. The Battle of the Bulge began at 5:30 a.m. on December 16, 1944, with a massive artillery barrage along an 80-mile front. Within hours, German armored spearheads, including King Tigers from the 501st Heavy Panzer Battalion, penetrated American lines. The weather grounded Allied air support, eliminating the one advantage that had previously countered German heavy tanks. For the first time since D-Day, German armor operated with near impunity. The fighting around St. Vith demonstrated the crisis. From December 17 to 23, American forces tried desperately to hold this crucial road junction. German armor, including approximately 18 King Tigers, hammered American positions. Sherman tanks attempting to defend the town were destroyed at ranges where they couldn't effectively return fire. American tank crews showed tremendous courage, closing to point-blank range to hit King Tiger weak spots. But the cost in lives and vehicles was unsustainable. General George Patton's Third Army wheeled north to relieve the surrounded town of Bastogne, but even Patton's aggressive tactics struggled against German heavy armor. On December 22nd, elements of the 4th Armored Division encountered King Tigers near Chaumont. The battle lasted 3 hours and cost the Americans 14 Sherman tanks. The King Tigers withdrew only when their ammunition ran low. Having suffered no permanent damage, by Christmas Day 1944, American casualties in the Bulge exceeded 80,000 men, with hundreds of armored vehicles destroyed. The desperate fighting produced a flood of after-action reports, all reaching the same conclusion. American armor was outmatched in direct combat with German super-heavy tanks. Something had to change. At Aberdeen Proving Ground, the urgency finally crystallized. The second T-95 pilot vehicle had completed its tests, and a third pilot incorporating final improvements was nearing completion. On December 28, 1944, a demonstration was arranged for senior officers, including representatives from Eisenhower's headquarters. The demonstration would determine the T-95's fate. The test was simple but dramatic. Engineers set up a captured German Panther tank's frontal armor plate at 1,000 yards, the standard combat engagement range. A Sherman fired first, using standard armor-piercing ammunition. The shell bounced off, leaving only a crater in the surface. Then the T-95 fired. The 90mm shell, traveling at 2,800 feet per second, punched completely through the plate, leaving a clean hole that would have killed everyone inside a real tank. Additional tests followed. The T-95 engaged targets at ranges up to 2,000 yards, demonstrating consistent penetration of the heaviest German armor. Its own thick frontal armor, 305 meters at its thickest point, proved effectively immune to captured German 88mm guns. Most impressively, despite its 95-ton weight, the T-95 demonstrated acceptable mobility in the muddy conditions simulating European winter terrain. The officers watched in silence, then reached their decision. On December 30, 1944, new orders went out. The cautious plan for 25 vehicles was abandoned. Instead, the Ordnance Department authorized immediate production of 100 T-95 vehicles, later redesignated as T-28 Super Heavy tanks. More importantly, the 3 completed pilots would be shipped to Europe immediately for operational trials under combat conditions. The rejected design had proven itself on American proving grounds. Now it would face the ultimate test: combat against the King Tigers in the frozen forests and shattered cities of Europe. January 1945 marked a turning point for American armor in Europe. As bitter winter fighting continued in Belgium and Germany, the first T-28 Super Heavy tanks prepared for deployment to the European theater of operations. The logistics of moving these behemoths would prove almost as challenging as building them. The first T-28, officially designated T-28 GMC Pilot No. 1, completed final modifications at Aberdeen on January 8, 1945. Its combat weight of 95 tons created immediate transportation problems. No standard military transport could carry it. The vehicle was too wide for most roads, too heavy for most bridges, and too large for standard rail flat cars. Engineers had designed the removable outer track system specifically for this problem. But removing and reinstalling the tracks required 6 hours and a trained crew. The solution involved a complex transportation plan. The T-28 would travel via specially reinforced rail flat car to the port of Newport News, Virginia. There it would board a heavy transport ship modified to carry extra heavy cargo. The voyage across the Atlantic to Le Havre, France, would take approximately 12 days, depending on convoy schedules and U-boat activity. Once in France, the T-28 would move by road to forward positions, but only along routes specifically surveyed for bridge weight capacity. Pilot No. 1 shipped from Newport News on January 15, 1945. Pilot No. 2 followed on January 28th. Pilot No. 3, the most refined version, incorporating all previous test results, would remain at Aberdeen for additional trials and crew training. The War Department authorized the formation of a special test unit, designated the 836th Tank Destroyer Battalion Provisional, specifically to evaluate the T-28 in combat conditions. The 836th was an unusual unit. Its personnel were handpicked, experienced tank destroyer crews who had proven themselves in combat, combined with technical experts who understood the T-28's complex systems. Captain James Parker, a veteran of the North African and Italian campaigns, took command. Parker had lost his previous command, an M10 tank destroyer, to a Tiger I during the fighting at Anzio. He understood intimately the problem the T-28 was designed to solve. Training for the T-28 crews began in February 1945 at a facility near Verdun, France. The soldiers discovered that operating the T-28 required different tactics from standard tank destroyers. Its slow speed meant it couldn't conduct the hit-and-run attacks that characterized American tank destroyer doctrine. Instead, the T-28 excelled at deliberate prepared combat, where its superior firepower and armor could dominate. Crews learned to position the vehicle in defensive positions, or to advance slowly behind infantry, destroying fortified positions and heavy enemy armor. By late February 1945, as Allied forces prepared to cross the Rhine River and enter Germany itself, the T-28s were ready for combat evaluation. Intelligence indicated that Germany was concentrating its remaining King Tigers and Jag Tigers to defend the Rhine crossings. This would provide the perfect test. American and German super-heavy armor meeting in direct combat. The deployment plan called for the T-28s to support the 9th Armored Division during the Rhine crossing operations. They would move into position near Remagen, where American forces had unexpectedly captured the Ludendorff Bridge intact on March 7, 1945. German counterattacks to destroy the bridge included heavy armor, providing exactly the target-rich environment where the T-28 could prove its worth. As March 1945 began, American soldiers manning the fragile Remagen bridgehead faced fierce German counterattacks. Unknown to most, the ultimate American tank destroyer was moving into position, ready to face Germany's finest armor in the war's final battles, March 12, 1945. The Ludendorff Bridge at Remagen had been in American hands for 5 days, and German High Command was desperate to eliminate the bridgehead. Intelligence indicated a major counterattack was imminent, including heavy armor from the 506th Heavy Panzer Battalion equipped with King Tigers. This would be the T-28's baptism of fire. Captain Parker positioned his 2 T-28s carefully. The terrain around Remagen consisted of rolling hills with scattered forests intersected by narrow roads, typical of the German Rhineland. Parker placed T-28 pilot number 1, call sign Anvil, on high ground overlooking the main approach road from Koblenz. Pilot number 2, Hammer, took a position covering the northern approaches. Both positions offered clear fields of fire extending beyond 2,000 yards, letting the T-28s use their range advantage. The German attack began at dawn. Infantry supported by Panzer IVs probed American positions, seeking weak points. American forces responded with artillery and mortar fire, driving the Germans back. But this was just the preliminary phase. Around 10:30 a.m., observers reported the distinctive engine sound of heavy armor approaching from the northeast. The King Tigers were coming. Sergeant Michael Chen commanded Anvil. A veteran of the Bulge, Chen had watched helplessly as German heavy tanks destroyed his previous M10 tank destroyer near Bastogne. Now, peering through Anvil's periscope, he spotted movement at 1,800 yards. 3 King Tigers advancing in line formation, using terrain for cover. Chen's gunner, Corporal James Rodriguez, already had the main gun trained on the lead vehicle's projected path. At 600 yards, the first King Tiger cleared a ridgeline, exposing its frontal armor. Rodriguez fired. The 90mm gun roared, the vehicle rocking despite its massive weight. Downrange, the tungsten core armor-piercing round struck the King Tiger's glacis plate. Unlike the hundreds of previous Allied shots that had bounced off King Tiger armor, this one punched through. The German tank stopped, smoke pouring from its hatches. The other 2 King Tigers immediately sought cover, their commanders recognizing they faced an unusual threat. One attempted to flank left, using a destroyed building for concealment. Chen rotated Anvil's hull, the 4 tracks providing excellent pivot capability. At range 400 yards, Rodriguez fired again. Another hit, another penetration. The second King Tiger burned. The third King Tiger commander was more cautious. He backed into a depression, presenting only his turret, and returned fire. The German 82mm gun was devastatingly accurate. The shell struck Anvil's frontal armor with tremendous force. Inside, the crew braced for death. But the T-28's massive armor held. The shell created a large crater in the casting, but didn't penetrate. Chen's crew was shaken but alive. The duel continued for 20 minutes. The King Tiger fired 6 more times, each shot hitting Anvil but failing to penetrate. Rodriguez fired 4 times, 1 shot missing, 3 hitting but failing to penetrate the King Tiger's angled turret armor from a downward angle. Finally, American artillery bracketed the German position. The King Tiger withdrew, trailing smoke from engine damage caused by near misses. The action at Remagen lasted less than an hour total, but its impact was enormous. For the first time, an American armored vehicle had faced King Tigers in direct combat and won decisively. 2 King Tigers destroyed, 1 damaged and withdrawn, against 0 American losses. The after-action reports spread quickly through Allied command. The T-28 wasn't just a theoretical success. It worked. The engagement at Remagen sent shockwaves through both American and German command structures. Within 48 hours of the battle, Allied intelligence intercepted German radio communications discussing the new American super heavy tank. German commanders, who had relied on the King Tiger's invincibility, suddenly faced a vehicle that could penetrate their strongest armor from ranges exceeding their ability to return effective fire. General Omar Bradley, commanding the 12th Army Group, visited the Remagen position on March 14, 1945. He personally inspected Anvil, examining the multiple impact craters on its frontal armor, where King Tiger shells had struck without penetrating. Bradley immediately ordered that both T-28s receive priority mechanical support and that their crews be decorated. More importantly, he authorized the deployment of additional T-28s as soon as they became available, but the significance went beyond one successful engagement. The psychological impact on German forces was substantial. Since the King Tiger's introduction in 1944, German heavy tank crews had operated with confidence that no Allied tank could threaten them frontally. That confidence evaporated at Remagen. Intelligence reports indicated that German tank commanders were now avoiding direct engagements with suspected super-heavy American tanks, fundamentally changing their tactical approach. The American response was equally dramatic. Through late March 1945, as Allied forces pushed deeper into Germany, the two T-28s at Remagen became legendary. Soldiers called them Kingslayers or Hitler's Nightmare. More practically, commanders requested T-28 support for any operation where heavy German armor might appear. The vehicles operated almost continuously through the final weeks of March, engaging various German armor with remarkable success. On March 24, 1945, during Operation Varsity, the Allied crossing of the Rhine north of the Ruhr, Hammer engaged a German Jagdtiger near Wiesel. The Jagdtiger, mounting a 128mm gun, was theoretically even more powerful than the King Tiger. The duel lasted over an hour. The Jagdtiger's 128mm gun scored 3 hits on Hammer's frontal armor, each impact spectacular but non-penetrating. Hammer's 90mm gun scored 2 hits at 1,700 yards, both penetrating the Jagdtiger's superstructure. The German vehicle was abandoned by its crew. These successes accelerated the production program. By late March 1945, 12 T-28s had completed production, with another 30 in various stages of assembly. The Ordnance Department projected that 60 vehicles would reach Europe before the war's end. While this was far fewer than the hundreds of King Tigers Germany had produced, it was sufficient to provide at least one T-28 to each advancing American army. However, the T-28 program also revealed the weapons limitations. Its slow speed meant it couldn't exploit breakthroughs or pursue retreating enemies. Mechanical reliability, though improved, remained problematic. Most critically, the T-28 consumed fuel at an enormous rate. Each vehicle required approximately 250 gallons per 100 miles, straining already stretched supply lines. These limitations meant the T-28 couldn't replace standard tanks, but rather complemented them in specific roles. German responses to the T-28 were limited by Germany's collapsing industrial capacity. Plans were drafted for new tank designs, mounting even heavier guns. But by April 1945, Germany lacked the resources to produce them. Instead, German forces relied increasingly on infantry anti-tank weapons. Artillery and desperate last stands in urban terrain where the T-28's advantages were minimized. As April 1945 began, with Allied forces approaching the Elbe River and Soviet forces encircling Berlin, the T-28 had fundamentally altered the arithmetic of armored warfare. The rejected design had proven itself the ultimate counter to Germany's super-heavy armor. April 1945 brought the final collapse of Nazi Germany, and with it, the last desperate deployments of German super-heavy armor. The T-28s, now numbering 8 in the European theater, participated in some of the war's final armored engagements. These battles would cement the vehicle's reputation while demonstrating the brutal reality of modern warfare's final evolution. On April 11, 1945, elements of the U.S. 2nd Armored Division approached the city of Halberstadt, approximately 70 miles west of Berlin. German forces had fortified the city with a combination of infantry, artillery, and critically, 4 King Tigers from the remnants of the 503rd Heavy Panzer Battalion. These were among the last operational King Tigers. On the Western Front, intelligence indicated the German commanders intended to make Halberstadt a fortress that would cost the Americans heavily. 3 T-28s, including the veteran Anvil commanded by Sergeant Chen, supported the assault on Halberstadt. The urban terrain negated many of the T-28's advantages. Streets too narrow for easy maneuvering, buildings providing cover for German anti-tank teams, and short engagement ranges all favored the defenders. Yet the assault proceeded because American commanders believed the T-28's armor would protect assault forces during the close-quarters fighting. The battle began at dawn on April 12th as American infantry advanced behind the T-28s. German forces opened fire. The King Tigers, positioned in prepared positions among the city's ruins, engaged at ranges under 500 yards. At such close distances, even the T-28's massive armor became vulnerable to the King Tiger's powerful gun. One T-28 call-sign Patriot took a direct hit to its track system, immobilizing it. The crew evacuated safely, but the vehicle was stuck. Chen's anvil pushed forward, using rubble piles for cover. At 400 yards, Rodriguez spotted a King Tiger's barrel protruding from a collapsed building. He fired the tungsten core round, punching through the building's remnants and striking the King Tiger's turret ring, the junction between turret and hull. The German tank's turret jammed, rendering it unable to fire. The crew bailed out. The urban battle lasted 3 days. By April 14th, American forces controlled Halberstadt, but the cost had been significant. All 3 T-28s sustained damage, though only Patriot was completely disabled. 2 King Tigers were destroyed, 1 captured intact but immobilized, and 1 withdrew successfully. More importantly, the Americans learned that even the T-28 wasn't invincible in urban combat, where ambush opportunities and close ranges negated armor advantages. The final T-28 engagement occurred on April 19, 1945, near Magdeburg. A single King Tiger, likely the last operational example on the Western Front, attempted to delay American forces crossing the Elbe River. The T-28, designated Hammer, engaged it at 200 yards across open ground. After a 20-minute duel, where both vehicles scored multiple non-penetrating hits, a lucky shot from Hammer struck the King Tiger's gun mantlet, penetrating into the turret and destroying the vehicle. By April 21st, organized German resistance in the American sector was collapsing. The remaining T-28s moved forward with advancing forces, but encountered no further super-heavy German armor. Most were still operational when Germany surrendered on May 8, 1945. Of the 8 T-28s deployed to Europe, 6 survived the war in operational or repairable condition, a remarkable survival rate for experimental vehicles in frontline service. The rejected design had endured every test: engineering challenges, skeptical generals, brutal combat, and Germany's finest armor. In the process, it had helped secure Allied victory in Europe's final battles. The surrender of Nazi Germany on May 8, 1945, ended the T-28's combat career, but the debate over its significance was just beginning. In the war's immediate aftermath, military historians, engineers, and commanders argued about whether the T-28 represented the future of armored warfare or an evolutionary dead end. The raw statistics supported the T-28's effectiveness. During approximately 8 weeks of combat operations, T-28s engaged German super-heavy armor on at least 15 documented occasions. They destroyed or disabled 7 King Tigers, 2 Jag Tigers, and numerous lighter armored vehicles. Critically, no T-28 was destroyed by enemy fire, though several sustained damage requiring repair. This combat record was unprecedented for any Allied armor facing German super-heavy tanks. General Dwight Eisenhower, in his post-war report dated June 1945, praised the T-28 program despite its controversial origins. He noted that the vehicle provided American forces with a psychological advantage during the final months of the war, demonstrating that American industry could match German engineering when necessary. Eisenhower recommended continued development of super-heavy armor for potential future conflicts. However, critics pointed to the T-28's limitations. Its slow speed made it unsuitable for the mobile warfare that had characterized the final Allied advance across Germany. Its enormous fuel consumption and maintenance requirements strained logistics. Most tellingly, only 12 T-28s actually reached Europe before the war ended, versus hundreds of Sherman tanks that bore the burden of actual fighting. Some officers argued that the resources invested in the T-28 program would have produced more impact if devoted to other weapon systems. The emerging nuclear age complicated these debates. By late 1945, as the world absorbed the reality of atomic weapons, many strategists questioned whether heavily armored tanks had any future. Nuclear weapons could destroy any armor, regardless of thickness. This philosophical shift contributed to the cancellation of the T-28 production program in October 1945. The Army retained the surviving T-28s for testing and evaluation. Through 1946 and 1947, engineers at Aberdeen Proving Ground conducted extensive trials, examining every aspect of the vehicle's design. These studies influenced the development of post-war American heavy tanks, particularly the M103 heavy tank that entered service in 1957. The M103 borrowed concepts from the T-28, including emphasis on frontal armor and long-range firepower, though implemented in a more mobile platform. By 1947, most T-28s were scrapped, their valuable steel recycled for peacetime industry. Only 2 vehicles were preserved. Pilot number 1, the vehicle that fought at Remagen, was sent to the Patton Museum at Fort Knox, Kentucky. There it remained on display for decades, a testament to American engineering and the soldiers who operated it. Pilot number 3, which never saw combat, was retained at Aberdeen for continued testing until being transferred to Fort Benning, Georgia in 1974. The T-28 story took an unusual turn in the 1970s. Pilot number 3 disappeared from Fort Benning's records, misplaced somewhere on the massive military reservation. For years, the Army couldn't locate the 95-ton vehicle. It became something of a legend, the lost supertank. Finally, in 1974, a survey crew discovered it in thick woods, partially buried and overgrown with vegetation. The vehicle was recovered, restored, and eventually joined pilot number 1 at the Patton Museum. The historical assessment of the T-28 evolved over decades. During the 1950s and 1960s, as Cold War tank design emphasized mobility and firepower over armor, the T-28 was often dismissed as a dinosaur, an overweight relic of desperate World War II engineering. But by the 1980s and 1990s, as military historians gained access to German records and conducted detailed analyses of the war's final battles, appreciation for the T-28 grew. German documents revealed the panic that T-28 sightings caused among tank crews. Former King Tiger commanders, interviewed years later, admitted that encountering the American super-heavy tanks fundamentally changed their tactical approach. The psychological impact had been as significant as the actual combat results. In an era when German armor had dominated through technological superiority, the T-28 proved that American engineering could compete at the highest levels. Modern analysis recognizes the T-28 as a specialized weapon system that performed its intended mission successfully. It was never meant to replace the Sherman or to fight mobile battles across Europe. Instead, it served as a counter to specific German weapons that threatened to make the final battles for Europe prohibitively costly. In this narrow but crucial role, the T-28 succeeded completely. The T-28 story also highlighted an important lesson about military procurement and innovation. A design initially rejected by the Army's established doctrine became a critical weapon when battlefield realities demanded new solutions. The willingness of engineers like Henry Hatch to persist despite opposition, and of commanders like Eisenhower to reconsider rejected concepts, proved essential to Allied victory. Innovation often requires challenging institutional thinking. Today, the surviving T-28s remain on display at the Fort Moore Military Museum in Georgia and in the collection at Fort Benning. Visitors marvel at the massive vehicles, trying to imagine the courage required to crew such a beast in combat. The armor still bears scars from German shells that struck but failed to penetrate, silent testimony to desperate battles in Europe's final days. The rejected American design that outperformed Hitler's most advanced tank became a symbol of American industrial might and tactical flexibility. In the great contest between Allied and Axis engineering, the T-28 demonstrated that innovation, persistence, and willingness to challenge doctrine could overcome even the most formidable enemy weapons. The super heavy tank may have had a brief combat career, but its impact on armored warfare history proved lasting and significant.